Alright, everyone. I think it's time to begin. Let's just go to our document, I guess. Let's do this. Okay. Nope, that is... that is the wrong screen. Okay, let's fix that. Sometimes it gets confused and it flips which screen is 1 and 2. Okay, that's like looking into the inverse fire. It's looking behind the scenes, right? Okay. So, good evening. Yes, it is. I guess it's evening since it's afternoon. So, today. That's a good question. I mean, it's a question that I don't particularly like, but I'll answer it. I don't know. I'll think about it. So, the merits of having a lecture on Wednesday is that it's required, and it's my job. The the potential downsides is that maybe no one will care or come. So I don't know. Conclusion, I don't know yet. I'll think about it. Okay, so today let's talk about the final exam. So I haven't written the final exam yet. I'm probably going to write it tonight or tomorrow or something like that. But, let me just say that the final exam is it's not going to be a complete, it's not going to be a complete shock, right? All right. In terms of the format, so the format is going to be basically the same as the other exams. So it's going to be some multiple choice questions on Blackboard, and then we're going to have some coding problems. And that's really it. I don't know exactly how many coding problems. I was thinking maybe 4 to 8 coding problems, depending. Since it's the final exam, like the thing is that fewer coding problems is less work, but it's the problem of like work times potential so in terms of multiple choice questions, I think it's going to be about the same. For coding questions, I think it's going to be just maybe a little bit more. So really what we want to do is we kind of want to minimize this, right? Because if we give like one problem, right, then total work is low, but potential danger per problem is really high. And if we give like 200 problems, then total work is really high and potential danger per problem is really low. But also that's way too much work. So basically we want to minimize this number or this function. Basically it's something that's going to kind of look, well, maybe not quite like that. It's going to look kind of like, it's going to have kind of like some kind of this performance, right? Where like the sweet spot is going to be somewhere between like 6 and 8 problems. Something like that. Right, so I've made a decision. We're not going to doing the integrity quiz. It's really too late for people to believe that cheating is bad. So what we're going to do instead is we're going to run a test on the. I know that every semester, even early on in the semester, all the way through the semester, everybody's always obsessed with this academic integrity quiz. The new submit system that Sean wrote. So that's going to be 20 points of basically free credit for helping us out. And so it doesn't mean, so what it means is no academic integrity quiz. What it doesn't mean is that cheating is good. Cheating is allowed. Still not good. Still not allowed. Okay. And so the new submit system assign will come out soon, and it's gonna. I mean, the thing is that there's nothing. It's not a hard assignment. It's we're just having you guys run a test as guinea pigs, so you're just guinea pigs. Guinea pig for the new test. It's like, and you get a free 20 points for that. So that's pretty cool. Okay. Yeah, I should have given the academic integrity quiz like before Project 1, and I just kind of forgot, and I just didn't do it. So we're gonna replace it. Okay. All right. So let's. I mean, yeah, I don't know. I'm not sure that the academic integrity quiz really does anything anyway. I mean, people who cheat probably cheat anyway, and making them click a button that says "I won't cheat," they can just lie on that. So, I'm not sure it ever really mattered. Okay, so cool. So now let's get into. And so basically, let me say what the new submit system is going to be. It's going to be basically a website that you go to, and you upload some code, and you run it there, and then basically you'll get some feedback for the output of the code, and that's basically it from your end. And the code that you have to submit, I think it's even given to you in the assignment that Sean wrote up. So it's not like it's not like you have to write up any really difficult code. I think the code is basically just given to you. The whole point is that we're just kind of trying to test it out and see what we're doing. Okay, so let's talk about CMSC 201. Right. So, what was this all about? Right? And so, the more probably useful question is, what did we learn? And what were we supposed to learn? And so the answer to that is that, so we were supposed to learn a bit about programming languages through Python. Yeah, I mean, we did learn Python, so specifically Python 3. If you ever need to do Python 2, it's much the same. There's a few little weird finicky differences about Python 2. Like, for instance, the print statement doesn't require parentheses on it because it's not considered, like, it is a built-in function, but it's like an exception. They got rid of all that for Python 3. So Python 2 still exists and is used in a lot of places, but the more important thing is, the way to think about it is, not that I learned Python, right? No. This is what to think. I learned basic programming in almost any language, right? Yes. So basically the point is that when you get to any other programming language, right, the first thing that you should really ask yourself is, at least in an imperative language, blah, 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 like you'll see some other languages, future, like functional languages, But for the vast majority of languages, like for instance C++, Java, well, I'm not going to say assembly language, C#, Python, Ruby. I guess we could put C, C++. You know, what are some other languages? I mean, technically, even JavaScript, if you call that a language, etc. Right? So all of these languages, what are the common features that they're going to have? Right? They're going to have variables, right? And variables generally have types. And the types of variables in most languages are going to be int, right? Just like in Python. There's going to be a float or a double. And the only distinction between float and double is that double is double accurate. So double is twice the size of a float. In Python, float is actually a double, so they just don't use the term double. Basically, this is decimals floating. The reason why they call it a float is because it has a floating point, right? And then you have strings of some kind. Really, normally you have characters. How do you spell character? There we go. And if you put characters together, you'll get strings, right? And so strings are in some languages, they are literally lists of characters. In Python, they're not a Python list of Python characters, but they are kind of a list of characters. You know, and then you have booleans, right? True and false. And so basically every language that I know of has to encode all of these data types in some way, right? And so some languages, like C and C++, they require you to specify the type. So for instance, in C++, what you're going to have to do is do something like int my integer, right, equals 3, like this. And of course in C++, there's a semicolon at the end of lines and stuff like that. So this is how you would do it in C++, whereas in Python, all you have to do is just do my integer is equal to 3. Now, you know that secretly this has a type, but the problem is that you can actually just right after it do my integer is equal to something else, right, where something else is a string, and so that's going to, you know, it changes the type of the variable, right? And so remember what that's called. So it's a little bit of a misnomer, but we generally call them non-typed languages. And so Python is generally thrown into the class of non-typed languages, whereas, for instance, like C++, Java are called typed languages. And the primary difference is that in a typed language, a variable like this my integer can only have this integer type because you've specified that it has an integer type. Here, this variable can change types, and so that's why they call it a non-typed language. The reason why I think it's a little bit of a misnomer is because generally it doesn't mean that there isn't type or that type doesn't matter, right? It usually mega matters all the time. You know, just try to add 3 plus a, right? And type will matter. In fact, you're even going to get like a type error in Python. So this is one of the fundamental concepts of programming, is the distinction between non-typed languages and typed languages, what it means to be typed. And typed does not mean typed on a keyboard. For some reason, my brain was like, oh, typed languages, like you type them. No. So it's a little bit of a misnomer because a non-typed language still has type. It's really, what we should call it is a type-changing language, right? Maybe non-typed, the better way to kind of call it is maybe a type mutable language versus type immutable, or something like that, right? And of course you might say, well, that's sounding more technical and less programmer friendly and all that stuff, and now I kind of agree with you, but also I think it's slightly more correct. I don't know. So anyway, So that's basically what to think about with variables, right? So variables. Remember how variables work? They need to be declared first before they're used. I don't think a single programming language, even in Python, the first assignment is considered the declaration. So, every programming language needs you to declare a variable before it's used. And basically, Ruby and to some extent JavaScript are non-typed languages. So JavaScript is kind of, maybe we'll put JavaScript kind of towards the middle. And of course you might be like, what the heck is the middle? The answer is that it's in the middle. That's all I'm going to say. It's slightly more typed than Python and Ruby, and it's less typed than Java and C++, C#, all the really heavily typed languages. So, but anyway, the point is that it's important to the thing is, this is the first thing that you should ask, right? When you learn a new programming language, the first thing that you're going to ask is, how do I declare variables, right? What's the syntax for declaring variables? And you'll learn next semester, if you take 202, that the syntax is type, name, equals, starting value, right? And here in Python, it's literally just name equals starting value. So, they're slightly different because, again, Python is quote-unquote non-typed. But anyway, so that's basically it for variables. Right? So then let's call these the, what do we want to call these? We'll call these the primitive variables. So what's the next thing you want to talk about? So let's not go immediately to lists, even though, of course, the first thing you're going to ask is, how do I make an array? How do I make a list? Let's go to the next thing in terms of the course order. So the next thing in terms of the course, right, are if statements, right? And of course, I guess the first thing you might ask is, how do I print and how do I input? And so in Python, it's print and input. In C++, it's either it's a cin or cout and cin, and in Java, it's system.out.println. Or I think, what is it? And then there's, I forget the input. It's like system.in.something. I haven't done Java command line input in a long time. Okay. So yeah, think about if statements. So what are the three things that generally if statements have? If statements have three keywords, right? There's the if keyword, there's the elif keyword in Python. I'm going to write else if here, and the last one is going to be else. Well, actually, let's write elif here, but elif stands for else if. So for instance, in C++, they actually do if, else if, and else. In Ruby, for instance, they kind of average them together, which is terrible. They'll do something like this. They'll do if, and then you're going to hate this, else if, like that, and then else. The extra s, it makes it different from Python. But they all function the same way, right? So the point is that these structures function nearly identically in all languages. And the reason why I'm going to say they function nearly identically is because you'll have an if statement and you'll have some kind of expression, right? And if that expression is true, then it's going to execute whatever in these brackets. Now, these brackets, or technically tabbed in or whatever, right? So if the thing is true, then it'll execute this, right? So this expression could be something like, if A is equal to 3 and B is less than 17, right? That's an expression. Or if the length of my list is less than 4 and my list 0, or let's say bigger than 4, just so that it doesn't actually, and minus 0 is equal to hello there, right? So these are all expressions, right? So we call these expressions. And the reason why we call these expressions, so an expression in a programming language, let me just write the definition down. So an expression in a programming language is a block of syntax. It's a block of code which, when evaluated, will return, well, so I guess I'll call this a logical expression. When evaluated, will return true or false, right? And I don't know if I should capitalize true or false or not. They're capitalized in Python, they're lowercase in C++, I think they're lowercase in Java, but it doesn't really matter. Like, the point is you'll figure that out. You know, so the idea here is that, you know, you have an if statement, you have logical expressions, right? Let's say logical. So whenever we say logical expression, we mean it's going to return true or false. The other type of expression are generally arithmetic expressions, and those evaluate into what should I say? Some kind of int or float, right? So, you know, but basically, okay, yeah. So logical expressions in a programming language return true or false. Okay, so basically every programming language, including Python, has if, some expression, we do something, else if, or elif, I guess. So colon maybe something, right? Elif other expression, and then we do something else, and then elif another, yet another. Well, let's just do another something cool, right? Elif, you know, yet another expression, right? Something less cool, and then finally else, right? Catch all. Well, I shouldn't use catch. Execute if nothing else did. Okay, so all right, so that's the general format for if statements. And so the number one thing to remember is that there's only one if, right? I think that's a universal truth. There's only ever one if in an if block, at least unless of course there's nested ifs. But I'm not talking about the nesting stuff. Okay, so there's only one if. The number of elifs are technically unlimited, right? You can have 100 elifs, you can have 1,000 elifs. The point is that you shouldn't have definitely should never have 1,000 elifs, but you can. You know, I should say, but you can in the sense that Python, C++, Java, Ruby, etc. Allows it, right? It's allowed, but it's not good. Okay. So, okay. So that's the, and then of course there's exactly one or zero technically else statement. So you don't need an else statement. You technically don't even need any elifs, obviously. You know, at this point you basically know that. I just want to go through everything from the course and just kind of review everything so that there's, I'm not spending too long on if statements, so I'm just going to push past if statements now. But yeah, there's exactly 0 or 1 else statements, and the reason why is, well, I guess we could say there are 1 or 0 else statements. So, else is not required. Even if you have elifs, right? You don't need an else. You can actually just do if, elif, done, right? You can do that. And you know all this by now. This is basically old hat. This is something you're very familiar with at this point. And so remember that this is our first little foray into controlling program flow, right? Because the thing is that when you just have variables, when you just have prints and input, you can't really control the program flow, because no matter what happens, right? Before if, elif, else, you can't really control what the program does, and in the sense that it's always going to execute the same instructions in the same order, right? So if there's a division by 0 problem, right? If you have if x equals 0, then you don't divide, else you do, right? So there's no way to prevent that kind of thing. Okay. All right. So that's the point. Controlling program flow is definitely one of. Obviously, it's what makes us. It's basically what separates a computer program from almost like a script. Even though some scripts are more like programs and can have if statements in them, but when you think of like a little bash script or something like that you might write, or even like a make file next semester, you generally wouldn't think of those as programs, even though they're sort of written in a kind of code. Generally, I think that the thing that makes a programming, of course, I'm kind of talking in the sense of, Turing here, right? What makes a computer different from like a calculator or some kind of different from a calculator or some kind of generic mechanism. And the answer to that should be, if you're kind of a Turingist, right? Alan Turing, and also I think Alonzo Church would both tell you something on the order of, if statements, right? Okay. And actually, I think they would also add in loops, but so let's talk about loops. Okay? So let's move on to loops. Loops are kind of what takes you from, early, computers that can just divide into two cases versus actually considering, a list of objects. So for instance, loops and arrays, which we in Python will call lists. So let's talk about for loops, right? So again, every language that I've told you about here has a for loop. Ruby actually has some additional kind of loops that are, well, I guess they're basically just for loops, but they're kind of done in a different way. But in terms of C++ and all this stuff, for loops are basically the standard loop structure. And the reason why I would say it's the standard loop structure is because what it does is the idea of a for loop is that you have some list or array or a set of numbers to iterate over. So you want to go from, say, 0 up to n, or maybe n minus 1, right? And so how are you going to do that? What you're going to have to do is you're going to have to write a for loop, because that's the thing that allows us to repeat code, right? So if statements allow us to branch, but branching is not repetition, right? And so if we can't branch, if we can't repeat code, then we're actually kind of limited. But as it turns out, once you are able to branch and once you're able to repeat a certain a segment of code, then you essentially have anything that you want to do inside of a computer, right? All the other things that are inside of computers, like functions, you know, recursion, classes, all of these other kind of higher level language features are really just built out of branching and repetition. Okay, so that's if we're being, and I think it's a good thing to talk about now that we're kind of reaching the end of the class. And we haven't really talked about the theory of computation, what it means to be a computer versus what it means to not be a computer. But yeah, so basically the idea here is that a for loop it makes the computer complete essentially. And so what are we doing here? So what we're going to do is, so in Python at least, we have two types of for loop. And they're not really strictly distinguished in Python, so Python doesn't really care about the distinction. But the distinction is kind of philosophical rather than being something more practical. It's hard to, but you can generally pick out. So there's some cases where you might not be able to completely determine, and that's because there's some cases where this distinction breaks down a little bit, like a for each loop is a for I loop. But basically in Python, there's two types of for loops. The one type of for loop is the for I loop, right? The for I loop. And so basically what that does is you always think of that as incrementing through either integers that track some kind of, generally I think that's the best way to put it. You increment through integers that track an index. The important thing is that the for I loop could really be called the for index loop, right? So that's the way to think about it. So let's do some examples of that. So okay, so here's an example. So if we have a list, right? So we say my list is equal to say 1, 2, 3, 5, 7, 2, 4. Here's a list, and then we say something like for I in range len my list, right? So this would be an example, and let's say that we say if my list at I is bigger than current max, right? Current max equals my list at I, and then we'll set current max equals 0. Okay, so this is basically a little bit of code that that'll find a maximum, right? So this is an example of a for I loop, right? The index is used, right? Now, could we write this as a for each loop? And the answer is yes. So what is a for each loop? So a for each loop doesn't exist in every single language. It's not a... So C++ added the for each loop. I think Java added it. It wasn't originally, back in the 90s and I guess early or late 80s with C++. It doesn't, it didn't exist initially, but a for each loop is something that will iterate so you can actually do the same bit of coding. So current max for each equals 0, right? And so what we can do here to do the for each loop, the distinction here is that, let's say for x in my list, right? And then we say if x is bigger than current max for each, we just set current max for each equal to x. I don't know, I put a semicolon there, and we print out current max for each. There we go. So these two pieces of code do the exact same work. In the end, the only difference is that one of them is a for I loop and the other one is a for each loop. So what's the number one way to not tell, right? So the primary trick or non-distinction or error, right, is to think, oh, if I see for I in something, that's a for I loop. No. Right? And the reason is because could I have just called this I? And the answer is yes, I could have, right? I could have just called this I. And would this make it a for I loop? The answer is no, because it does. So remember, it's not for the variable I, it's for an index. So if there's an index, that makes it a for I loop. If it's actually looking at values in the array or the list or the dictionary or something, that's a for each loop. So that's the distinction, right? So the distinction is not what the variable is called. So remember that even if the variable is called I, that doesn't matter, right? You got to check whether it's an index or an element. That's the distinction, right? So, yep. Okay, cool. All right. So what's next? So I guess the next thing is while loops. So while loops, they run while a condition is true. So basically, the way to think about while loops is that, let's say that you do a while loop while, I don't know, what's a good thing to do a while loop for? Let's say while n is bigger than 0, and let's do n is equal to int input enter an integer, and then let's just do n divided equals 3, and so we'll print n, and then here we'll print out count, right? So, and of course count needs to be set to 0, count needs to be incremented. Okay. So let's enter an integer. So the integer we're going to enter is, say, 281,391. And so we see that what this is doing is it's just dividing it by 3. And so when do you use a while loop over, so basically the question is always, when should I use a while loop over a for loop? And so the 99% answer for this is whenever you don't know how many times the loop will run, right? So, and it's a little bit dangerous to say that because you might say, well, I don't know the length of the list, but as it turns out, Python does, right? Like if I have length of my list, right, we pretend that we know this, right? Because we can access the length of the list. In a function like this where we're dividing by 3 each time, or we do some other more complicated mathematical process, we don't necessarily know how long the thing is going to run because I could send, I can enter, 9999999, a whole bunch of extra 9s, and then this time it's going to run, say, 28 times instead of what it ran last time, which was like, who knows? So the point is that you don't know how long the thing is going to run, and so because you don't know how many steps it's going to take, that's when you use a for loop, right? That's when you use a while loop. So basically, the answer is whenever you don't know how many times the loop will run. So if the loop is going to run, say, from 0 up to a number n that gets inputted, right? That's for territory. If you know that there's a list you want to iterate through, for. When you're getting user input, and you don't know how many times the user's going to screw up, right? That sounds like a while loop to me. When you're running a server and getting messages, or running some kind of graphics user interface, the thing is that, of course, back when we did those lectures, I ran a like main loop, or for instance, in the server program, it was just myapp.run, right? But the secret is that basically the secret is that there's a while loop in here, right, in this function. Right, the function itself is just a function, but the thing is that there's some big while loop that's running in there. You don't know much else about it, but you know that, right? So that sounds like while. There's certain mathematical approximation things that you might do with while, but if you don't know how many times, if it's just like while the error is bigger than some specified amount. Okay, so that's all while. Alright, cool. Alright, so that's basically when you should use a while loop over a for loop. So basically, it's whenever you don't know how long the thing is going to run. And so remember that if we put in, say, -1 here, right? The answer is that what happens is, remember that the while loop does not have to run, so that's an important fact. While loops don't have to run. They can run 0 times if the first condition is false, right? And while loops have another fun feature. That they can run forever. We call that the infinite loop, right? So they can run 0 times. I guess for loops can also run 0 times if the list is empty or something like that. But while loops can run 0 times if the first condition is false, and they can also run an infinite number of times. So you can have something like while x is bigger than 0, and if you use the wrong variable, right, and we just run this thing, so let's say we've entered 5, and so this is just going to run forever, well, or until Python explodes, or right until the computer decides you're done, or whatever kind of problem that's going to cause in the hardware, the software, the operating system, or something like that. But you see that this is a pretty simple mistake, and it's one of the type of mistakes that it's very easy to make. Is you just accidentally use the wrong variable name, and all of a sudden you're stuck in an infinite loop. So infinite loops are definitely, so I'll say they're more possible with while loops. There is a way to get an infinite for loop in Python, but let's just say that most for loops can't be infinite loops. And by most, I mean like basically nearly all. It's like minus 0. Right? So you have to basically, in order to get an infinite for loop, you sort of have to, I think what you have to do is you have to make like my list equals some list, like 1, 2, 3, 4, 5, something like this. And then you basically, what you have to do is you have to say for x in my list, and then you can do my list dot append x plus 1. And so what you can do here, and then let's print out my list each time. And I think this might be an infinite 3. Yeah, so this is an infinite for loop in Python, because what it's going to, well, okay, so it's basically just adding an element every time, and so we're never going to actually get to the end of this list. So this is an infinite for loop in Python. The answer is that most languages don't really let this happen. So I'm going to say I don't think, I guess you can have an infinite for loop in C++ as well. You can also, but generally for loops can't be infinite loops. at least not as easily. While loops are the ones that are usually more dangerous. So, yeah, generally we would say that. So this is an exception, right? This is not something. This is not the rule, right? So the rule is that for loops are much harder to make into infinite loops, but and let's just never run that function, right? Okay. So, all right. So that's loops. So let's talk about the most important thing. So after loops. So basically, if you know variables, you know if statements, you know for loops, you know while loops. The next important thing that we covered in this class are functions. And functions are a huge topic, right? The thing about functions is that there's a lot to talk about. So what do we talk about with regard to functions? Right, the answer is basically, so this is also a form of repetition. But it's not like a loop because it's not repeating itself, right? That would be, I guess, a recursive function. But functions are also a form of repetition, but what they are is that they allow code to be repeated from other points, right, of your program. They allow, abstraction to start. Like, they're the first level of real abstraction in coding, because the thing is, before you have a function, all of your code is kind of just in one big blob, right? And it's very difficult to unblobify your code, because if you just had if statements and for loops and more if statements and more for loops and more if statements and more for loops, then that would be an issue. Everything would just be this long mess of garbage. But with functions, it allows you to repeat code from any other point in your program. So it allows you to basically separate out a piece of functionality, and it allows you to have that functionality run separately. And so the advantage is, the reason why functions are so good is actually because they allow local variables. Now, you might say to yourself, well, local variables are something I have to get used to. It's something I have to think about. It's something that's a little bit more difficult. I wish everything could just be global. But the answer is, actually, it's better that there are local variables. And the reason why it's better is that with a local variable, what that allows you to do is you can do some intermediate processing calculation, right? You can do some of that stuff, but whatever variable name you pick, right, won't be sort of taken up in the global space. And also, the other good news is that no one ever has to, about you accidentally changing their own local variables or other globals that you don't have access to, unless of course you're changing global variables. But generally, you shouldn't be changing global variables, and the reason why is because it's just good programming practice. Now, there's nothing in the law of the universe that says you can't use global variables and functions, and sometimes you have to use global variables and functions. Sometimes it's better that way. It's not, there's always exceptions to this. So remember that all these. Let me just say this about all the rules that we teach. So when we teach a rule, like global variables are bad, right? What are we actually saying? What we're actually saying is that in general, you want to avoid the use of globals, not because they're bad, but because what it does is it improves your own code, right? So you want your code code to run correctly, regardless of what other people do in other functions, right? Like, let's say that you and 10 other people write a piece of software, and you write function A and they write functions B through H, or I don't know why I said H, but yeah, B through H or B through J or whatever. So all kinds of functions, right? They write all kinds of garbage. And the only rule that everybody follows is that everybody only uses local variables until the big global program, right? So the big global program calls everything with the local variables. And so what you know is that, and I don't think we're really teaching the rule that global variables are bad, but let me just say that what we're really saying is not that global variables are bad. We're not saying that. What we're saying is we're avoiding them because if your function has a problem, then you know one of two things, right? One, the input is bad, so other code is wrong, right? Or two, the function is bad. The function and you see, this is good, right? And the reason why this is good is because if you can prove to yourself, right, that the input is good, right, and the function's still producing bad input, as long as you're not using global variables, as long as everything that's being done is contained within the function or within its parameters, then you know that the function needs to be fixed. And that's great because what is the hardest, part of coding? And so I don't know if you've learned this yet, but I think you probably have in this class, is, you spend, say, 10 minutes coding something, you spend 50 minutes debugging that thing, right? And so basically think about it this way. If you use global variables, sometimes globals can decrease this coding time from, say, 10 to, say, 5 minutes, right? But then if there's a bug, debug time and testing time go up from 50 to, say, 100 minutes, right? So that's why we teach this. We teach this because the idea here is that if you have local variables and you keep it to local variables when you can, again, there's always exceptions, right? There's always times where it's better to use a global variable and all that stuff, but then you have to remember, right, that if you use a global variable and all your functions are using that same variable, then if a function produces bad input, you don't know that that function is wrong. It could be a function that happened before it that messed up your global variable that then produced bad output from your function. So that's the reason why we do this. And that's like the long explanation that we don't really give during the course, but it's important to say it because I think that in general, when people get out of a class like this, they end up saying global variables are, people say short little rules like global variables are bad. But let me just say that if global variables were that bad, there would be programming languages that just didn't allow them, right? If global variables were just horrible objects that just should not exist, then some set of programmers out there would have written a programming language. Like, for instance, there's a programming language called Rust, which does certain things that C++ doesn't do in certain ways, and they wrote this language specifically to fix certain problems with C++ that it has. C++ allows you to do some dangerous things that always blows up in people's faces, right? Python doesn't allow you to do that stuff. Python actually fixes it. Java mostly fixes it. Rust fixes it in a different way. And so you see that if global variables were truly bad, then they would be non-existent in certain languages, but actually, as it turns out, even in Rust, in Java, in C++, in Python, in Ruby, there are always global variables. And so they're not a bad thing. They're simply something that if you can avoid using them, they help to kind of isolate your code. They keep your code kind of, to use a COVID sort of term, they keep your code quarantined, right? Your code is not able to spread its bugs to other functions. That's not a bad way to think about it. Okay, so what are some other things about functions? So functions are obviously the most important thing in the universe, right? So what are some other things about functions? Well, what other kinds of things do we know about functions, right? Functions take arguments, and arguments are sent in as parameters. And so parameters are the variables, they're like the local variables inside the function. And arguments are the values sent in, right? And remember that I absolutely do not care about the distinction here. So, but I know that there are some programmers who might care, so that's why I'm teaching you the distinction in the language. So an argument, so for instance, like if I say f of def f of x, and we're just going to return x, say squared plus 2x plus 3, and so if you say f of 3, right, then we would say 3 is the argument, right? X in the f function is the parameter, right? So that's the distinction. Now, you might say, well, I don't really care so much about that distinction. Like you could say, oh, the parameter 3 or the argument x, and well, okay, so I shouldn't say nobody, but almost nobody is going to argue with you about that distinction. After you leave this class, it's really not going to be a big deal. I think that it's important to know. So the thing is, like, I think that these kinds of distinctions are always important to know, and and the reason why I think they're important to know at this point is I think it's kind of like coding interview questions. Okay? And so I hate to say it, but this is kind of the stuff that they ask you when you go in to get a job. You're going to sit down, and they're going to be like, hey, looked at your resume, you graduated from UMBC, like, blah, blah, blah. And then they're going to ask you, they're just going to be like, so, what kind of things are in a class? Or, like, what does a class do, right? Or they're going to say, like, what's the difference between a local and a global variable? I mean, they're probably not going to ask something that simple. That's like more like an internship interview type question. But they might ask you something like, how does recursion work, right? Or something like that. And so, it's usually like the first real kind of question that they ask you after they get your personality down a little bit. So, and so they might ask you like, oh, what's the distinction between an argument and a parameter? And they, some of them think they're really clever to ask these types of questions. And the thing is that, like, there's no substance in here. It's simply a, terminology question. And that's why we teach the terminology, is because you got to know it. It's something that I think it's terminology that doesn't really serve that much of a purpose, but it's definitely stuff that, if it means you're going to get a nice job that's going to pay you 80 grand or 90 grand or 100 grand, then maybe it is worth knowing the difference between an argument and a parade. That's the way to think about these types of slight semantic differences. Is just kind of know them and just kind of think about them in the sense that, like, no one really cares until, of course, you get asked that question during your, Google interview, and you're just like, oh crap, if I don't get this question right, I don't get my Google job, and then I have to go and, flip burgers or something. So, okay. So the point here is that that's the distinction between arguments and parameters. And so remember, I think the two most important things about functions are to talk about scope, and to talk about mutable versus immutable, and parameters, which also in this case are going to be passing by value versus passing by reference. So let me explain again what these two terms are. So maybe I'm going to do, I think next time, this has been mostly a lecture on terminology. It's been mostly a lecture going over everything. I mean, it's kind of been an overview of what we've talked about in the course, kind of like the 1,000-foot thing. I think next time what I'll do, so I think I will have a lecture on Wednesday. The lecture on Wednesday is going to cover two things, I think. I think it's become clear at this point that the lecture on Wednesday should cover actual coding examples for the final. So we will do practice problems. So this is like the theory practice for like multiple choice. And so we'll do some theory, so actual practice problems for the final, which I kind of wanted to do now, but I just didn't for whatever reason. And so, and the other thing that we might do if we have some extra time is like Python beyond 201. So I might talk about list comprehensions. I might talk about some other things that you're not allowed to use in this class, but the point is that you should know them if you're going to do Python. So I'll teach them on the last day so that you don't use them on the final, but you at least know them so that when you go forward in your future life, you can know them. Okay, so what is the distinction between passing by value and passing by reference? So passing by value means that we're going to make a copy of the argument and pass that copy into the function, right? And so what does that mean? That means that the copy cannot modify the original variable, right? And that's the most important thing here. So the original variable, I'll call it the original like global variable, or really what I really mean is outside of the function variable. So it could be a variable that only exists as a local variable in a different function, but the point is that it's global with respect to us. It feels global to us because it's coming in as an argument or parameter. So, okay, so the copy cannot modify the original. And so basically what that is like, if I have something like def edit my string, right? And we say my string, the string, and then we say, okay, the string dot replace. I think, let me see if I can do this. O is that, let's replace all the A's with B's, okay? And so what we're gonna do here is then we'll print out this. And now, of course, you might say, let's just say the string equals the string dot replace, print the string, and then what we're going to do here is we will say edit my string. Let's say global, or oh no, the big string equals let's see, Apple Baker Charlie Dog. All right. And so we're going to edit the string, right? And then we're going to print it out again. And so let's see what happens here. So let's print this out. 4. Okay. So what do we see that happened, right? What happened in this example? And I mean, I know you've seen basically this example before. Technically replace is forbidden, but I don't really care. The point is here, it did Bebel, Baker, Shirley, Derg, right? So, Shirley Derg. And so, what do we see that happened, right? All the A's got replaced with B's by this thing, and it printed out the replaced string. But you notice that what, right? The big string out here was not changed, right? And so the question is, why? And now, of course, most of you are going to say, well, we didn't return it, right? Well, okay, sure, but that's not 100% an answer, because if you notice, what happens is the big string goes into the edit, right, my string function, and so it becomes the string, right? It becomes this Abel, Baker, Charlie, Dog becomes the big string. It goes into the function. It's in here. It gets modified, right? The string is changed. But then, the big string is not changed, right? So what happened, and, most of you are saying, well, the answer to that is it passes by value, right? Obviously, because that's, what I said way a long time ago, that passing by value. And so remember what passing by value means is it makes a copy, right? So passing by value means it makes a copy. So this string inside here, the string, is actually a copy of the big string from outside. So when we modify it and we do this, it doesn't actually modify this variable here, it only modifies the local version, right? So you can consider it, so there's two ways to think about it, right? Either it makes a copy, or basically, well, yeah, I guess it makes a copy and that copy only has local scope. That's the way, that's like the perfect way to say it, right? It makes a copy and that copy has local scope. So, well, what's the difference? What do we do? What is passed by reference, right? And so these are two terms that I promise you gotta know. Like, it's weird. They're strange sounding terms. I don't use them all that much because I don't actually particularly like them, because I think that the terms are a little bit confusing actually for what they really means. But passing by reference. So let me tell you what a pass by reference means. Pass by reference is we don't make a copy, right? Basically, the way to think about passing by reference is that the stupid way to say it is the local variable is a reference to the variable outside of the function. Now you might say, but that's using a word in its own definition. That's not a good way to define things, blah, blah, blah. So once you learn more about exactly what references are, so you'll learn about what references are in C++. A reference is something where a certain variable is linked to another variable or another memory location. It's kind of like a pointer. It's like a pointer with a little bit less memory location flavor is really what it is. Basically, it's a pointer with a little bit of the memory location hidden from you. But the point is that you don't have to worry about that right now. But when you pass by reference, it doesn't make a copy. And so when we don't make a copy, what we have is secretly the parameter is actually just a renamed variable from the global/outside scope. Okay? And so that's what it really is. So basically here, let's make something that operates this way. So let's say the list is equal to, say, 1, 2, 3, 4, 5. And then we say def modify my list, right? And so then what we're going to do is, let's say, definitely not the list, right? And so here what we're going to do, we have this stupid function. And you notice this function also doesn't return anything, right? Immutable types are passed by value and mutable types are passed by reference. That's, no, so that you're right. So remember, this is basically the moral of the story in the very end is that mutable, so in Python, so this is a Python specific thing. This does not go to other languages. So this is very different. So this is like a Python specific thing. And so mutable things are passed by reference, and immutable things are passed by value. And you might think like, okay, but is there the same mutable-immutable distinction in C++? The answer is no, actually. There are constants in C++, but it's definitely not, it's not the same. And basically in C++, there's, and in other languages, so for instance, if you want to make a function, my function, and you want to have some like variable, let's say you want to pass it by reference, there's actually a way to do it. You just use the ampersand, my ref, right? So that's now a reference to the original variable. Whereas if you do something like this is passed by value, this is passed by reference. But this is a C++ thing, right? And so we don't have that in Python, and so that's why Python makes a different choice, right? So Python chooses just to pass everything that's mutable by reference and everything that's immutable by value. So of course you might say, like, oh, if I really need to modify a string, tricky string mod, right? What we could do is, instead of passing something immutable like a string, we could pass something mutable like, say, the stupidest way to do it would just be to stick the string into a list. So my list of strings, and so what you do is you say, my list of strings 0 dot replace A's with B's, and then we can just reassign that into there. And then, because the my list of strings is mutable, even if the object inside it isn't mutable, this is still going to do it. So we could do a tricky string mod where we do something like this. Baker, something like this. And we could do tricky list equals this, tricky list, and then we could print out the tricky list like this. So this is bad. You shouldn't be doing this, but I'm just saying, like, it's possible, right? So you see that here, if you really wanted to, you could always just stick a string into a list as the one element, and it could be, this is like a mutable string, right? Because the list is mutable, and the string is just stuck inside the list, and you can kind of modify it this way. I mean, is this good? No. Is this tricky? I'd say yes. Is it kind of silly? Also yes. Right? So that's the way to think about this type of thing, right? What's a better way to do it? I mean, I guess you could even pass in, if you really wanted to modify it, you could even just like listify the string. So for instance, what you could do is you could do something like this, maybe something a little bit better, like that, and then you could say, instead of doing this, you would say for I in range len my list, of strings, and you would say my list of strings, and let's just comment this out. So let's say my list of strings at I is equal to my list of strings at I, unless of course if my list of strings at I is equal to A, then we set it. What am I doing? There we go. And then, so let's see here. So here it's doing this, and this is probably the better way to do it, and then you could always just like join it back together. Right, so there's ways to do this that are, I would say that this is a slightly better version of a mutable string, is where you actually just like listify it into a bunch of characters, and then you can modify the characters one by one. I don't know. I mean, maybe this is dumb. So every programming language has some weird things sometimes you just have to get over, and this is one of them. So basically, yeah, so if there's an immutable type that you want to pass as a mutable thing, there are ways to kind of trick your way around it. You can stick it inside of a mutable object and then pass it in, and that's how you can kind of cheat the system. Okay, so if you learn nothing else from the course, so the good news is that this is basically what you really desperately need from this course, right? Classes, it's good if you know them. You're going to get retaught them in C++. Recursion, it's good if you know it. You're going to do more of it in C++, but you probably won't do nearly as much of it in C++ until you get to data structures. So basically, like, those two topics are kind of like, the way to think about it is classes. The reason why I teach classes is because Python is kind of built for it, so it's better to use them, and so it's better to know them. Even though they're kind of a little bit annoying to get used to, it's a little bit hard to but maybe next semester, and maybe you should come back and tell me if you think that learning classes this semester has helped you next semester, and that's really my main goal there. And then for recursion, you might think, well, why do we have to learn recursion? And the answer is 341. Entirely 341. Data structures is a class where everything, with a little asterisk on that, almost everything requires at least one recursive function per project. The reason why it requires recursion is because all of the data structures are basically these objects which are defined as nodes, and the nodes can have additional nodes popping off of them. And so you can't just loop through all the nodes. You have to actually say, okay, what if I go right? What if I go left? And unfortunately, the best way to do that is recursion. There are other ways to do it, but the best way is recursion. So next time I'm going to do some, so let's say next time on CMSC 201, which will be our last class, I'm going to do some actual coding examples, right, of final type questions. Is the list of required things recursive? Sometimes, yeah. So we'll do actual coding examples, and then I'll talk more about like recursion classes, and then 3 we'll talk about future Python, right? And this is Python, not just, it's Python like list comprehensions, ternary expressions, etc. So things that you should know, but I haven't taught you. And I know that that's a silly way to say it, but basically the excuse is that there's, you might say, well, why didn't you teach us these things? And the answer is, well, actually, the list of things you should know is essentially infinite. And the time that we have is finite. So we have to select some subset of, some infinite thing, things you should, know, things we teach, right? And so it's a subset that's not equal, right? So things we teach are a proper subset of the things you should know, and unfortunately we can only really teach a finite set of things, and there's always, for anything you should know, there's always an additional thing you should know, so that's why we don't teach them. That and other reasons. They also they can cause confusion and overcomplicate things, and they don't exist in all languages, so there's reasons that we don't teach them. So, but anyway, if you ever ask, like, man, if why would you say that I should know something that you're not teaching? The answer is, well, you should know a lot of things that I'm not teaching. That's why this is not the last class in the degree, right? This is the first class in the degree. I teach you the most basic stuff that you definitely need to know to get you through the next class, which then you learn more of the stuff that we teach, and you'll get a bigger impression of the list of things that you should know, right? So unfortunately that's life, right? The list of things you should know is always bigger than the things that you get taught, and it's always bigger than the things you currently know. So that's why should know is always in quotation marks. All right, so that's my opinion about life, I guess. Yeah. All right, so I think that's good. We'll do another final exam review next class, and we will talk about things, I guess, right? We'll talk about all 3. Well, hopefully we'll talk about all 3 of these things, and then I will release the final Wednesday or Thursday. It'll be on the 14th, which is, I think, the Thursday. Oh, the 13th, which is the Thursday. And so I'll release it then, and then, you'll have until the end of finals to complete it, and then that'll be fine. Okay, that's it, everybody. Seal the ports.